Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go.
Welcome to lesson 16 of GMAT Math Basics. Today, let's talk about exponents. You're going to see a good number of exponents questions on test day, probably about 10 to 20% of your section, so it's very valuable to understand what we're going to discuss. Also, even though the topics that we've already covered recently, such as divisibility and percentages, do come up more often than that, exponents are not always as intuitive for folks to understand as those things like arithmetic, fractions, and percentages. So I hope that you'll find today's talk very valuable. Let's do a quick quiz based on what we'll cover in this lesson. First question, what is an exponent and how does it work? Next, what are the basic exponent rules? For example, what can I do with exponents when I'm multiplying by the same base? What can I do with exponents when I'm dividing by the same base? What can I do with exponents when I'm taking an exponent to another exponent? Next, how do negative exponents work? Next, what happens when I raise a number to the exponent of 0? We'll discuss how exponents work when multiplying or dividing terms versus adding and subtracting terms. So, do you already understand that? How do exponents work when you're multiplying and dividing versus when you're adding and subtracting terms? What does it mean to square a number? And finally, what does it mean to cube a number? Let's dive in to the basics of exponents. Question 1, what is an exponent and how does it work? Exponents represent multiplication and sometimes division. And that's it. Let me explain. What if we consider our recent conversation about interest on capital? Let's say you have a $100 investment that grows at 10% annual interest, but you don't just want to know how much money you'll have in 2 years, like we calculated in some of the problems we did in the previous lesson. What if you want to know how much money you would have in 20 years or 100 years? Well, from the previous lesson, you now understand how to execute that math. But what if you wanted to write it out or maybe put it into a calculator or an Excel formula or something like that? That's going to be super annoying for most people because you're going to have to write out 110 over 100 20 times. So that's why we have exponents. Exponents are basically a shorthand that says multiply by the same thing a certain number of times. So when you want to multiply by the same thing a bunch, that's when exponents come in really, really handy. Let's get into some definitions. What you're multiplying is called the base. That's the base of the exponent. More on that in a minute. And how many times you multiply by the base is called the exponent. That's what an exponent is. It's how many times you're going to multiply by the base. I'll say that again. What you're multiplying is called the base, and how many times you are multiplying by the base is called the exponent. Let's use some examples. If we say take 5 to the third power or raise 5 to the exponent of 3, that means multiply the number by 5 3 times. Now that might mean multiply 5 by itself, or it might mean multiply something else by 5 3 times. Either way, it works the same. Now, just a quick aside, and we'll go through a couple more examples here because I think these basic definitions are important, especially if you haven't thought about this in a decade or two. The way you speak exponents when you're reading them or speaking them to someone else is take the base, whatever the base is, to the quote unquote exponent, whatever the exponent is, power. Whatever the exponent is called the power that you're taking the base to. So if we want to multiply 5 3 times, or we want to multiply something by 5 3 times, we say we're taking 5 to the third power, or 5 to the power of 3. 5 is the base, 3 is the exponent. Another example, if we say take 5 to the 10th power, or raise it to the exponent of 10, or raise it to the exponent 10, that means multiply by 5 10 times. So again, the base is the thing that you are multiplying or multiplying by, and then the exponent is how many times you want to multiply by that number. So one final time, what you're multiplying is called the base, and how many times you multiply it is called the exponent. Let's return to our interest example for 20 years. If we wanted to know the total interest that we would earn, we would multiply $100 by 10 over 100 20 times in a row. Imagine writing that out by hand. Obviously, it's doable, but not exactly most people's idea of a good time. Instead, we can use an exponent. And to do this, we would write 10 over 100, and then in the area called the superscript, or what some of you might understand as being like slightly above the middle of the line that we're writing in. So we've got 10 over 100, and then up and to the right of that is the superscript area. We would write the number 20. Usually the way this is written is you would have parentheses around the 10 divided by 100. So 10 fraction bar below that 100. You'd have parentheses around that whole thing. And then up and to the right of the rightmost parenthesis, you would write 20 in a smaller font size, slightly above and to the right of the parentheses. But it would still be like very close to the parentheses if you haven't seen this before. It's almost touching. It's a slightly smaller font size up and to the right. That means take 10 over 100, which is the base, to the exponent of 20, or multiply by 10 over 100 20 times in a row. That's how it's written. So we talked about how it's spoken, what it means, and how it's written. Let's use a simpler example to drive home the visual here. If we want to multiply 5 by itself 4 times, we would write 5, and then up and to the right of the 5, which is called the superscript area. That's distinct from the subscript, which is down and to the right. Superscript is up and to the right. We would write 4 in a slightly smaller font size. That's how it generally appears on the exam. Again, the exponent itself, the number of times you're multiplying the base, is usually a smaller font size when written up and to the right. And that's how you can distinguish this during the test. Now, sometimes online, it's inconvenient to use keyboard shortcuts or formatting techniques to write it that way. And so what's sometimes used on like forums and things like that, or in textbooks, is something called a caret symbol, C-A-R-E-T. And that represents the exponent. On my keyboard that I'm looking at, it would be shift and then the number 6. So it's the second function of the number 6 key on my computer keyboard. That's the caret symbol. It kind of looks like a small triangle without the bottom side. You can think about it like that, like a little hat. Or maybe think about it as like an arrow with no tail pointing upward. It's kind of funny to describe this symbol, but hopefully you can visualize what I'm talking about. If you see that, that can represent taking a base, to a power or an exponent. Same thing. So example, if we want to express 5 to the 4th power in this way, we would write 5 and then the caret symbol right to the right of 5, and then 4 right to the right of the caret symbol with no spaces in between any of those. So it's just 5, and then immediately the character to the right is the caret, and then immediately to the right of that is the 4. So when you're using this notation, the exponent is usually the same font size as the base. And this is part of the reason it's used. It's just you don't have to mess around with the formatting too much if you're just quickly typing a text or a reply on a forum or something like that. It's just a convenient notation to use. And so I want you to be familiar with it. The GMAT itself does not use that notation on test day. At least I've never seen them use that notation on test day. That's more like a colloquialism, if you're familiar with that word. It's just like a common practice of let's call it internet lingo, internet way of writing things, which is the low investment way of writing it. But it is very convenient and it's faster usually for folks to write it that way, especially if certain forums don't have specific formatting tools. And so you might see that frequently during your prep, and I want you to be prepared for what that means. So back to our interest example, let's think about how much more convenient it is. Instead of writing 10 over 100 20 times in a row, imagine writing 10 over 100 times 10 over 100 times 10 over 100 times 10 over 100 by hand 20 times. Instead, we just write parentheses, 10 over 100, and then up and to the right of the parentheses, we write 20. And that's almost 20 times less writing than we would otherwise have to do. So it's a very efficient notation. It's very, very helpful. And that's part of the reason that exponents are valuable. Now, there's a point that's worth making here, which is at the end of the day, it's still just multiplication. And that's really, really important. I'm going to drive that point home as we go through the lesson, because I think sometimes when you're looking at it, it can look very complicated and it can be kind of intimidating for certain types of folks, especially if you feel like you've never been good at math, or you just maybe know you have potential, but you didn't have great math instruction as a young person, which is also extremely common, much more common than you might think. Or you just had great math instruction, but just didn't study hard for that particular exam in school, and so the exponent thing never stuck for you. I'm going to really drive home that it's just multiplication. It's just a different way of expressing, hey, multiply by this thing a bunch. And I think if you understand that concept, then all the rules that we're about to talk through are going to make a lot more sense, and they're going to be a lot more usable. But it is definitely a useful way of writing multiplication that saves a lot of time and energy, and hence its popularity and why it's used widely. So that's the basics. Let's get into how exponents work. Exponents have been around for a long time, and they get used in a lot of different situations. For example, they get used frequently in fields like computer science, in fields like engineering and physics, fields like finance. And so people have done a lot of things with exponents, and that's led to the discovery of some basic rules that apply when you are using this exponent notation. The GMAT likes to test these rules quite a bit, so it's very worth knowing them, and that's why we're going to go through them right now. Let's go ahead and learn them one at a time. First rule, what do we do with exponents when we're multiplying by the same base? So for example, let's say that we're going to do 5 to the third power, or 5 to the exponent of 3, times 5 to the exponent of 4. So there we have the same base, 5. If you imagine writing that out physically, 5 to the third power would be 5 times 5 times 5. And then we're multiplying that by 5 to the fourth power, which would be times 5 times 5 times 5 times 5. So ask yourself, how many times in a row would we be multiplying by 5 in that situation? And hopefully you're thinking 7 times. Three 5s multiplied together at the beginning from 5 to the third, multiply that by 4 more 5s, 5 to the fourth. Total times we're multiplying by 5, 7 times. So the result of this could be written as 5 to the 7th power. And that works 100% of the time, by the way. When you're multiplying by the same base, you can just write them out like that and count up the total number of times you're multiplying by the base and write that as a new exponent. That's quite labor intensive, though, especially when you get to exponents like 5 to the 20th or 5 to the 200th power. And so people like to generalize this rule by saying, if you are multiplying two exponents with the same base, you can simply add the exponents. It's a great shortcut. It works extremely well, and it's definitely worth memorizing. In fact, all these rules that we're going to go through are very worthy of flashcards. If you're not already just comically rock solid, fluent with exponent math. If you are, then by all means, keep doing what you're doing. A couple more examples of this. How could you rewrite 7 to the third power times 7 to the sixth power? Again, how could you rewrite 7 to the third times 7 to the sixth? Hopefully you're thinking, well, we're multiplying by the same base, 7, so I can just add the exponents. 3 plus 6 is 9, so I could rewrite that as 7 to the ninth power, or 7 to the power of 9. Both of them are accepted ways of speaking that mathematical expression. Again, you could write it as 7 and then no space, the caret symbol to the right of that, and then no space 9 to the right of that, all in the same font size. Or you could write a 7 and then slightly up and to the right with a slightly smaller font size. You could write the 9. Both work. Another example. How could you rewrite 3 to the 10th power times 3 to the 13th power times 3 to the 8th power. Again, 3 to the 10th times 3 to the 13th times 3 to the 8th. Hopefully you're thinking it's all the same base, 3. So I can just add the 3 exponents. 10 plus 13 plus 8 is 31. So that'd be 3 to the 31st power, or a total number of times that we are multiplying by 3, 31 times. That's what many consider to be the quote-unquote like first rule of exponents, or just a rule of exponents. When you're multiplying by the same base, you can add the exponents. Again, it's just a shorthand, similar to exponents itself, so that you don't need to sit there and write out 3 times 3 times 3 times 3 times 3, 31 times in order to figure out what the result is going to be. Like, that would also be really cumbersome if you think about it. 3 times itself 10 times, then write out 3 times itself 13 times, then write out 3 times itself 8 times, and then count all of them up one at a time. That's going to be quite labor intensive. And it's a lot more convenient to simply recognize that when you are multiplying exponents with the same base, you can add the exponents. Next rule. What can you do when you are dividing exponents with the same base? It's a similar type of rule, and it also comes down to basic operations. For example, let's say we wanted to divide 5 to the 5th power by 5 to the 3rd power. Imagine writing that out for a moment. Let's say we've got a fraction, and on top of the fraction, we've got 5 to the 5th, which is 5 times 5 times 5 times 5 times 5, so 5 5s in a row. And then below that fraction bar, we've got 5 to the 3rd, or 5 times 5 times 5. Imagine physically canceling 3 of the 5s in the top with the 3 5s in the bottom. Imagine physically canceling those out. If you don't know what canceling means, you might want to check out lessons 3, 4, and 5 of this series, which is divisibility, fractions, and remainders. Talk you through all that stuff. What would remain if you had 5 5s on top and 3 5s multiplied together on the bottom? You would have 5 times 5 only on the top, which would be 5 to the 2nd power, or as we'll later discuss, 5 squared. So people often make this into another quote-unquote rule of exponents. And the way that rule is often articulated is when you're dividing by the same base, you can subtract the exponents. You might have noticed that 5 5s on the top, 3 5s on the bottom. If you subtract the exponents, you wind up with 2 5s, or 5 times 5. A couple more examples of this. How could you express 9 to the 7th power divided by 9 to the 3rd power? Hopefully you're thinking, dividing by the same base, I can simply subtract the exponents from one another. That should be 9 to the 4th power, 7 minus 3. Of course, you can also visualize it as 9 times itself 7 times on top of a fraction, 9 times itself 3 times on the bottom, and canceling 3 of those 9s, leaving 9 times itself 4 times on the top. And feel free to write that out enough times until these rules click for you or make sense. Another example. What about 14 to the 3rd power divided by 14 to the 2nd power? That would equal 14 to the 1st power, or simply 14. Anything to the 1st power is just the base by itself. Many people consider this rule the quote-unquote second, or simply another rule of exponents. When you're dividing by the same base, you can subtract the exponents. Again, it's a great shortcut so that you don't have to write out 9 times on the top of a fraction if you don't want to. Super, super useful. That's why we're going through them. So that's the first and second rule of exponents. Next rule. What if you're taking an exponent to another exponent? Let me use an example. What if we wanted to take 6 to the power of 4, or 6 times itself 4 times, and multiply that by itself 10 times? So we wanted to do 6 to the 4th and then multiply that 6 to the 4th by itself 10 times in a row. We can do that. The way you could write it would be 6 with a 4 in the superscript, so 6 with a small 4 up and to the right, and then that whole thing in parentheses, and then up and to the right of the parentheses, a 10. That's how the exam itself commonly would write an exponent to another exponent. It would write it like that. Or you can use the caret symbol, 6, caret, and then 4 in parentheses, and then another caret right to the right of the parentheses with no space in between, and then a 10 right to the right of the second caret symbol with no space in between that either. Okay, both of those mean 6 to the power of 4, and then that whole thing to the power of 10. By the way, when you're doing this, you'll usually have parentheses around the first base or exponent, and then the outside parentheses, you'll see the exponent up and to the right of that. Again, just very, very common. I want to be as clear as I possibly can be with that for all of those of you who are on audio. Again, this is a great shorthand because it keeps you from having to write this out a bunch of times in a row. If you were to write out 6 times 6 times 6 times 6, and then write that 10 times and manually count up all the sixes, you would count 40 sixes. But that'd be quite a lot of writing stuff down. And so instead, we use the next rule of exponents, which is when you're taking an exponent to another exponent, you can multiply the exponents. You might have noticed that 6 to the power of 4 to the power of 10 yields 6 to the power of 40. And a nice shortcut for that is just multiply the exponents when you are taking one exponent to another exponent, or what's sometimes called taking a power to a power. So 6 to the power of 4, and then that whole thing to a power of 10. That's another common way that that is stated verbally. A couple more examples of this. How would you rewrite 2 to the 5th power, and then that whole expression to the power of 7? Hopefully you're thinking 2 to the power of 5 to the power of 7. I multiply the exponents. 5 times 7 is 35. And so I could rewrite that as 2 to the power of 35. Another example. What about 8 to the power of 3? And then that whole expression to the power of 5. Hopefully you're thinking 8 to the power of 3, that whole thing to the power of 5. I can multiply the exponents. 3 times 5 is 15. So the result would be 8 to the 15th power, or 8 times itself 15 times. Once again, just imagine writing those out by hand. You could totally physically write out the math if it helps, and I'd recommend that at least to get the concept down, but you would wind up writing 8 times 8 times 8 times 8 a lot of times. And during the exam, it's probably better to use the shortcut, let's be honest. Now, I'd recommend memorizing all of these. I think I already recommended that, but just driving that point home. When you're taking a power to a power, multiply the exponents. Again, great to know why it works because it'll probably help you remember it. At the end of the day, if you just memorize the rules, that would probably be enough to quote unquote get by on the exam. But I'm assuming none of you just want to get by on the exam and that you're looking for like a peak score or your personal peak score. And so I'm trying to give you the right amount of depth of instruction here where we're not going down to the protons and neutrons level of math, but we're still hopefully giving you the story behind exponents to hopefully make it make sense. I think things that make sense tend to be easier to remember. Maybe that's just me. Now that you understand those rules, it brings us to the topic of negative exponents. So let's answer the question, what is a negative exponent? What does that mean? How does it work? Consider the example of 5 to the 1st power. That's just 5. 5 to the 2nd power is 5 times 5, and 5 to the 3rd power is 5 times 5 times 5. Hopefully that's not a revelation based on our conversation so far. Let's dig deeper into what's happening there. As I'm adding 1 in the exponent, what does that represent? Hopefully you're thinking that represents multiplying by the base one more time. So every time we add 1 in the exponent, that represents multiplying by the base one more time. So what would happen if we subtract 1 from the exponent? Well, to get from 5 to the 3rd down to 5 to the 2nd, what would you have to do? You would have to divide by the base. So imagine 5 to the 3rd on top, dividing by 5 to the 1st on the bottom. That's how you're going to get 5 to the 2nd. So if you've internalized that exponents represent multiplication by the base, now's a good time to realize that negative exponents represent division by the base. Consider this example. What if you wanted to take 100 and divide it by 5 6 times? One way to write that is 100 times 1 over 5 times 1 over 5 times 1 over 5 6 times in a row. And if you visualize doing that math and multiplying 100 times 1 across the top and then a bunch of 5s across the bottom of the fraction, you might realize that you would wind up with 100 divided by 5 to the 6th power. You might recognize that that 5 to the 6th power in the bottom of a fraction represents dividing by 5 6 times. And because negative exponents represent division by the base 1 time, you can also write that as 100 times 5 to the negative 6th power. When you take 5 to the negative 6th power, that means divide by 5 6 times. So we're just inverting what exponents are. 5 to the 6th power means multiply by the base 5 times. 5 to the negative 6th power means divide by the base 6 times. That's the basics of how negative exponents work. Positive exponents represent multiplication by the base. Negative exponents represent division by the base. And that's why you'll often hear the following rule about negative exponents, which is negative exponents represent 1 divided by the positive version of the exponent. Now, you might not have understood why that is, but now you do. Negative exponents represent division by the base. You'll often hear people recommend that you write 5 to the negative 6th power as 1 over 5 to the positive 6th power, which is totally accurate, by the way, and also a totally acceptable technique. Really, I think how you use these rules comes down to personal preference. As long as you understand the rules themselves, you should be in good shape. Let's do a couple more examples. What if I asked you to rewrite 7 to the 6th power, 7 to the power of 6, times 7 to the power of negative 4? How would you rewrite 7 to the 6th times 7 to the negative 4th? There's actually a couple ways that you could rewrite this. Let's explore them both. You could rewrite it as 7 to the 6th power divided by, with a fraction bar below it, 7 to the 4th power. Because again, 7 to the negative 4th could be rewritten as 1 over 7 to the positive 4th power. So you could just express that as 7 to the 6th over 7 to the 4th, and use the rule that we talked about before of when dividing by the same base, you subtract the exponents. And in that case, you would get 7 to the 2nd power. Now, the other way to do that is you could use the multiplying by the same base, add the exponents rule. So if you think 7 to the 6th times 7 to the negative 4th, you can just add 6 and negative 4, the two exponents, and that would also yield 7 to the 2nd power. Either way works. There's times and places for both. And for a lot of you, it's simply going to come down to personal preference. Whatever in the moment you think is the optimal way to handle that situation, you can handle it that way comfortably. Ideally, you're at least familiar with both methods, though. Hence our desire to go through them right now. Let's do another example. How about 4 to the negative 9th power divided by 4 to the positive 3rd power? So 4 to the negative 9 divided by 4 to the positive 3. How would you rewrite that? Again, two ways you could do this. You can use the dividing by the same base means subtract the exponents rule. So you think 4 to the negative 9th divided by 4 to the 3rd. It's the same base, so I just subtract the exponents. Negative 9 minus 3 would yield negative 12. So that would be 4 to the negative 12th power. That's one way to rewrite that. The other way you could rewrite it is 4 to the negative 9th times 4 to the negative 3rd, because dividing by a positive exponent is the same as multiplying by the negative exponent. And then you could simply add negative 9 and negative 3 to get negative 12. That's another way of writing it. There's actually a third way of writing it, which is you could rewrite 4 to the negative 9th power as 1 over 4 to the positive 9th times 1 over 4 to the positive 3rd. That would also work. And then you can just multiply straight across the top. You get 1. Multiply straight across the bottom and use the rule that when you're when you're multiplying by the same base, you add the exponents, and that would get you 1 divided by 4 to the positive 12th power, which hopefully now you realize is the same as 4 to the negative 12th power. It just means take 1 and divide it by 4 12 times. All these ways work. Like I said before, you should ideally be comfortable with all of them because the exam can provide answer choices in a variety of forms that are interchangeable. Again, it's part of the reason I'm going through this with you right now so that you're prepared on test day. That's it for negative exponents. I think if you understand those things, you should be good to go. Now, quick tip with exponents. Sometimes it can take more than one repetition to really get these to be super comfortable. So feel free to create some drills for yourself using a Gen AI tool like I've recommended in the past. Reach out to us if you're not sure how to do that. And or feel free to re-listen to this episode enough times that this becomes very, very natural for you to think through and manipulate exponents this way. Let's move on. Now that you understand negative exponents, it should be easier to understand the concept of taking a number to the 0 power. So let's answer that question. What does it mean to take a number to the power of 0? This is a much more conceptual thing than the other ways that we've been using exponents so far, which I think tend to be a little bit more practical, like they're often used more in the quote-unquote real world. Having said that, the GMAT does like to test this concept of taking things to the power of 0, and so it's very worth understanding. Let's think about 5 to the second power for a second. Like we've discussed, that's equal to 5 times 5. If we subtract 1 from the exponent, like we were talking about with negative exponents, that makes 5 to the 1, which is just 5. So again, subtracting that 1 from the exponent represents dividing by the base. And think about what we've done there for a moment. Imagine we had an equation that says 5 to the second equals 5 times 5, which is true, hopefully, obviously. And imagine dividing both sides of that by 5. That would yield the equation 5 to the first equals 5. Now, let's say we decided to divide both sides of that new equation by 5 again. So on the left side, we would have 5 to the first divided by 5 to the first. And imagine we use the dividing by the same base, subtract the exponents rule. That's going to be 1 minus 1 in the exponent, and that would yield 5 to the 0. And on the right side, imagine we are also dividing by 5. We would have 5 divided by 5, which would yield the number 1. Yeah, that's one way you can prove to yourself that 5 to the 0 power equals 1. Many of you may have memorized in the past that, quote unquote, anything to the 0 power equals 1. But let's explore a little bit more about why exactly that works. Imagine any number to the first power. That's just the number itself. And then imagine subtracting 1 from the exponent. What does that subtracting 1 from the exponent represent? It represents division by the base. And virtually any number divided by itself is equal to 1. So that's why almost any number to the 0 power is equal to 1. Because if I start with the number to the first power and then subtract 1 from the exponent to get it to the 0th power, that represents dividing by the base. The base divided by the base is equal to 1. There's only one exception to this. You might have picked up on I was saying virtually any number. So there's only one exception, which is 0 to the 0 power, which is technically undefined because division by 0 is not this is kind of a complex topic in math, but basically just remember that division by 0 is not allowed because there's not a number that represents that value. You don't really need to worry about that on the GMAT. It's not something that's tested. You just need to know that it's off limits. Like as long as you know that dividing by 0 is just not allowed, pretend like you just can't do it. Pretend it's impossible, and that's more than enough for the GMAT exam. Now, if you want to get a PhD in math, then you're probably going to think about this a lot and a lot deeper, and you can go into all the nuances of that. But I think that's probably going to be a distraction for all of you who probably don't necessarily want a PhD in math, or at least that's not what you're doing right now. You're just trying to get a really great MBA. So we will stick to the basics in this course. I do want you to learn it accurately, though. So I don't want you thinking that any number to the 0 power is equal to 1, because that's technically not true. But the main focus should really be on memorizing that any non-zero number taken to the 0 power is equal to 1. And that's something you're definitely going to use at certain points throughout your GMAT prep. And the good news there is that's pretty much every basic rule of exponents that's worth knowing for the exam. There are many more complex strategies, but again, this course is about the basics. And let me just delineate that. So there's complex math that you definitely don't need to know to do extremely well in the GMAT, even get a perfect score. But then I'm now talking about like other strategies that are worth knowing for the GMAT, but that's going to go beyond just the basics of math. So we'll cover that elsewhere. So let's just stick to the math basics for the GMAT in this course. Now, one more thing that's worth noting. You might have realized that all of these rules apply to multiplication and division. And we haven't talked at all about what to do when you're adding and subtracting exponents. So let's discuss that a little bit. Unfortunately, and this is really important, these rules we just talked through do not work when you're adding and subtracting exponents. Let me illustrate this. If I'm asked, what is the value of 5 to the 7th times 5 to the 8th, I can just add the exponents and get 5 to the 15th. But if I am asked what the value of 5 to the 7th plus 5 to the 8th is, it is not equal to 5 to the 15th. That's really important. You can play around with this with a calculator and a few examples to prove this to yourself. Let me give you a quick example that'll hopefully help. Imagine 2 to the 2nd power times 2 to the 3rd power. That is 2 to the 5th power. Or you could think about it as 2 to the 2nd, which is 4, times 2 to the 3rd, which is 8, or 4 times 8. Either way works. You're going to get 32. If you did 2 to the 2nd times 2 to the 3rd, and then you compute all the math, all the exponent math, you'd get 32. Or if you rewrite it as 4 times 8, you would also get 32. Notice that if we combine the exponents first and added them because we multiplied by the same base, we would get 2 to the 5th. Same thing. So those expressions are equivalent. But importantly, let's do 2 to the 2nd plus 2 to the 3rd. That's 2 squared 4 plus 2 to the 3rd 8. 4 plus 8 equals 12, which is not the same as 2 to the 5th. That's really important. There's plenty more examples of that you can derive on your own or just think through right now. Again, these rules apply when you're multiplying and dividing exponent expression. They do not apply when you're adding and subtracting exponents expressions. Now, why that doesn't work is actually not super important for your GMAT score. I guess if you're really curious, it's worth digging into. But the really important thing is just to memorize it and to memorize that those rules do not apply to addition and subtraction, because the fact that it does not work is extremely important. So why it doesn't work, not super important for your GMAT score. The fact that it does not work, very important, because it's very tempting in the moment to be like, oh, 2 to the 2nd plus 2 to the 3rd, that's just 2 to the 5th. And yeah, that would definitely make the problem easier if it was accurate. But that's just an easier way to get the question wrong. And perhaps, obviously, that's not why we're here. So again, that can cause many, many mistakes on the exam if you don't internalize it properly. So let's steer clear of that. So remember this. The basic rules of exponents almost always apply when multiplying and dividing, and almost never apply when adding and subtracting. If it by chance works out, then that is only by chance. It's not actually like a mathematical proof that you can use reliably, okay? So if you want to operate on 5 to the 7th plus 5 to the 8th, what do? You can't use any of the rules we just talked about. So what you should do is remind yourself that you cannot use those rules. Again, to avoid that temptation, so it can get very strong in the moment, especially under time pressure. And instead, you want to internalize that you try to factor out a common term. When you're adding and subtracting exponent expressions, you do not use the rules. Instead, you try to factor out a common term. Just going to repeat that one more time because it's really, really important. If you're adding or subtracting exponent expressions on the GMAT, do not use the rules we just talked through. Try to factor out a common term instead. Very worth memorizing, very worth flashcards. You want to internalize this to a massive degree. It might seem weird that I'm going so hard on this right now, but I mean, it would be hard for you to imagine how many times I've seen extremely capable, extremely intelligent people do this mistake on GMAT exams. So we actually touched on factoring during our fractions episode a few episodes back. Again, that's lesson 345, if you're not really sure what I mean when I say factor out a common term. But to just rehash the basics quickly for the sake of convenience, so you don't have to go leave this right now and go back to it, but you should later if you're not 100% sure what I'm talking about. When you're factoring, you're looking to divide by a number that divides the two other numbers evenly. So 10 and 5 can both be divided by 5. That means you could factor out 5 from an expression with 10 and 5 in it. I'm just making this up as an example. Let's say we've got 10 plus 5, and we want to factor out a 5 from both numbers. We could transform that into 5 on the outside of a set of parentheses, and then 2 plus 1 inside the parentheses, because 10 divided by 5 is 2, and 5 divided by 5 is 1. So if I have 10 plus 5, I can divide each of those by 5 and turn it into multiplying outside a set of parentheses, 2 plus 1. Now, we'll get to distribution later. If you know how to distribute, though, you might imagine redistributing that 5 times 2 and 5 times 1 and getting back to 10 plus 5. You could see that that's equivalent. Now, I'll also prove to you that it's equivalent right now, because if we add 5 times 2 plus 1, we can just add 1 and 2 to make 3. That would become 5 times 3, which you'll notice has the same value as 10 plus 5, 15. Both of them yield the same thing. They are equivalent expressions. So you're allowed to do this because you're not changing the value of the expression. You're just changing how it looks. It's kind of similar to finding a common denominator in a fraction. It's a very useful technique, especially when you don't have a calculator. Now, let's think about an example where that wouldn't work. What if we were doing 7 plus 5? There's no number that divides 7 and divides 5 other than 1. And so we're not going to be able to factor anything out of that. But usually the GMAT doesn't present you with those types of situations, which I think is interesting. So when you see addition and subtraction with exponents, ask yourself, is there a number that could divide both or all of the numbers that I'm adding or subtracting? Let me just repeat that. When you see addition and subtraction with exponents on the exam, ask yourself, is there a number that can divide both or all of the numbers that I'm adding or subtracting? You want to look for that common factor that you can factor out. Let's return to our example of 5 to the 7th plus 5 to the 8th. So is there a number that can divide 5 to the 7th and divide 5 to the 8th? Yes, there is. 5 to the 7th power can divide both of those numbers. So let's do that. 5 to the 7th divided by 5 to the 7th is just 1. And 5 to the 8th divided by 5 to the 7th is just 5. So we can rewrite that expression as 5 to the 7th times a set of parentheses surrounding 1 plus 5. And then we can just do the addition of 1 plus 5 to turn it into 5 to the 7th times 6. Now, let's think about what we just did there for a moment. We took something that used to be addition, and we transformed it into something that is now multiplication. So it used to be 5 to the 7th plus 5 to the 8th, and we transformed that into 5 to the 7th times 6, which has the same value. Why would that be a good idea on exponents questions? Hopefully you're thinking, well, now I can use all those exponent rules that I know because now it's multiplication, not addition and subtraction anymore. It's a very valuable technique. Now, in this particular example, 5 to the 7th times 6, it would depend on what the rest of the problem was. That's probably not going to be a whole problem on the GMAT. But you get the idea. Factoring out a common term is awesome because it takes something that used to be addition or subtraction, where you can't use the rules of exponents, and transforms it into something that is multiplication or division instead, where you can use the rules of exponents. Very, very powerful move to be able to make. That's all you need to know about the basics of exponents for now. Like I said, there are more advanced strategies out there, but I'll give you plenty of opportunities to learn those from a variety of sources. And if you're looking for that kind of support, just go back to our episode, probably, 20-ish, 30-ish weeks back now, to the very beginning of 2024, where I'll talk you through all the options that I think are the best this year for you to learn those more advanced strategies, depending on your budget and your timeline and all sorts of specific individual factors. Next time, we'll discuss roots, which are related, but I personally think it's worth separating those out so that we don't confuse anyone, because yes, exponents and roots do have a lot in common, but I think conceptually for a lot of people, they seem very, very different. And so I want to separate those concepts for you so we don't cause any confusion. Now, I just want to tack on a couple quick, very small points to the end of this lesson. These are not nearly as important as what we just discussed, but it's still worth mentioning. And that's because the exam can sometimes use different terminology, different words to describe the operations that we were just talking through. So for example, when a number is taken to the power of 2, such as 4 to the 2nd power, that's often said or described as squaring the number 4. Or it might be said as 4 squared. And if English is not your first language or you haven't done a lot of math with English, that's probably going to be a little bit weird. Like, what does squaring 4 mean? If you're not familiar with this way of describing taking these numbers to the 2nd power, it's very worth memorizing. It actually comes from geometry, where you will sometimes take the side length of a square and multiply that by another side length to find what's called the area of the square. Now, geometry is not very heavily tested on the GMAT anymore, so we're not going to touch on it very much in this series. But most of you at some point in your past have probably found the area of a square, which is a rectangle with 4 equal sides. That's what a square is, if it's been a minute. And when you are multiplying a number times itself, that came to be called squaring the number over time because of this familiar operation from geometry. A square has equal side lengths, and so when I multiply the base times the height, I am multiplying the same number by itself. And that's the same as that number to the second power. So these things just kind of became synonymous over time, meaning the same thing. And so now we have this convention in English that squaring a number means taking it to the second power. Because you might see the term squared on the GMAT, it's worth knowing what that means. It just means take the number to the second power. Quick example, 5 squared is the same as 5 to the second power, which is the same as 5 times 5, which is the same as 25. Relatedly, the square of a number represents the result of squaring a number. So you might see that terminology as well, such as what is the square of 5? The square of 5 represents squaring the number 5. So in my last example, 25 is the square of 5. You may see this terminology on test day. Again, flashcard it if you feel like you might forget it. Once again, if you don't really know how to make good flashcards, quick web search or quick Gen AI prompt should help. Last, you'll also want to know what it means to cube a number. It's a very similar concept from geometry. When finding the volume of a cube, you multiply the base times the height times what's called the width, or sometimes called the length times the width times the height of the cube. And a cube is a three-dimensional depiction of a square. It's a three-dimensional box shape where every side length is the same. That's called a perfect cube. And so when you're finding the volume of that cube, you multiply the length times the width times the height. And because the length, width, and height are all the same number in a cube, it has become over time popular to say that cubing a number is the same as taking it to the power of 3. You might also hear people say the cube of a number, which is the result of cubing that number. Or you might see something like 4 cubed. So 4 cubed means take 4 to the third power. Cubing the number 4 means take it to the third power. And finding the cube of 4 means taking 4 to the third power. They all basically mean the same operation. But again, that can be kind of confusing if you haven't heard that terminology before. So just trying to help streamline this for you. 4 times 4 times 4 is 64. So just to help solidify this, 64 is the cube of 4. Again, the exam can use this terminology, and I've found it to be confusing, especially if English is not your first language. So really hope that quick conversation helps you out. Let's recap. You'll want to know what exponents are, which is just a shorthand for multiplying by the base a lot. You'll also want to know the basic rules of exponents, which is also a shorthand, so that you don't need to write out a ton of bases when you're doing large exponent calculations. You'll also want to understand what negative exponents are and how 0 works as an exponent. These are more technical aspects of how exponent works that the exam likes to test, even though they're not as common in the quote-unquote real world. Finally, you'll want to know what the terms squared and cubed means, just in case you're not familiar with them already. So I'll invite you to restart this episode if you want to re-quiz yourself on this information, because I left that quiz for you at the top of the episode. And you're also welcome to go through every episode of this series. And I have a quiz for you at the beginning of every episode so you can test your knowledge of GMAT Math Basics and see what you might want to dive into and what you maybe don't need to dive into. And maybe you are in a position where you can just move on to those more advanced strategic operations that I detail in How to Start Your GMAT Studies in 2024. It's not the very first episode of this podcast. That's from back in 2019. This is a specific update for the new version of the exam that just came out this year, and I strongly recommend listening to that. If you are like, how do I learn these more advanced strategies? I'll give you a bunch of different options based on the current state of the GMAT market. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content if you want to just click it and not type it into the browser. And check out our free video presentation there on how to achieve your dream GMAT score in half the normal time. It's totally free, very, very valuable. In the meantime, this is a weekly show, so please subscribe and please stay positive and stay consistent with your studies. I'll talk to you all soon.